Just give us a second.
Okay.
You can stick the rest of that cord in your front pocket.
Okay. How you guys doing today? Okay. Well, welcome everybody. How you doing today? Made it through all the snow and everything. Welcome to Ford Motor Company and the CAD/CAM department. What we do here, actually we'd like to share with you today some of our business experiences. So we're all very happy to have you here. And what we do in this department is we develop, maintain, develop, and enhance a tool that Ford Motor Company uses to build cars. And the tool is called CAD/CAM, which means computer-aided design, computer-aided manufacturing. It's one of the unique things about Ford Motor Company as opposed to some of the other companies in the automotive industry is we develop our own and maintain our own CAD/CAM system, whereas many other companies buy their systems from other companies to use. Now there are many CAD/CAM systems, but the one that we mainly use within Ford is called PDGS, or Product Design Graphics System. And our intent here is really just to give you a quick overview of what PDGS is, what we do here, how it came about. Mainly what we like to do is focus on giving you a chance to work with the system yourself. And so what I'd like to do is take about 10 minutes, just show you a quick video, because it can explain this a lot better in a lot quicker amount of time than I can. Show you a quick slide presentation, and then we'll work on the big screen, show you some of the things that the system can do. So, let me get this started. And we'll give you 10 minutes here.
Since the dawn of time, man has searched for ways to improve his methods of transport. These drawings found on cave walls in France depict early man's world. In this newly discovered cavern, we see how man was already thinking about improvements. And we think we know what our visionary and his tools may have looked like. He has left this self-portrait. Time marches on, and people developed more sophisticated modes of transportation. And they developed new design tools. This tool was known for its portability and aerodynamic qualities. This latter-day tool offers many advancements. These images show the evolution of the automobile and of our industry. Evolution is a good term for this progression, for one of the basic principles of evolution is survival of the fittest. Only those manufacturers who are able to deliver products which satisfy the wants and needs of their customers will survive. Sophisticated tools are necessary to engineer and design the automobiles that will help us survive in our industry. These images show people working on our CAD/CAM systems. CAD/CAM stands for Computer-Aided Design, Computer-Aided Manufacturing. During the next few minutes, we'll show you why CAD/CAM tools are so important, how they are used, and who is using them. We'll also point out some of the benefits our users are finding, which improve the quality and timing and reduce the cost of our products. There are two CAD/CAM graphic systems at Ford Motor Company, CADS and PDGS. CADS is used to develop powertrain systems. PDGS is used at all other activities. The name PDGS stands for Product Design Graphics System. It is a menu-driven program. Work is done by choosing menu options. There are no commands to remember, and the user needs no prior computer experience to learn PDGS. This designer is working on a fender. As he creates the part, the computer stores the lines and surfaces as a mathematical data model, or math model of the part. The three-dimensional design capabilities of PDGS means that when a part is created, the lines are drawn only once. All views are generated from the 3D math model of the part by PDGS. Parts can be rotated. You can pan across the part or zoom into particular areas. When the part is approved, it is released and maintained as the master source of data. CAD the master pilots are using the CAD data as the only source of data on the part. Drawings or physical models, if produced, are used for reference only. Released parts are stored on computers like these, called data collectors. Users with appropriate access authorities from anywhere in the world can bring a part to their local disk. The CAD data is released for other users to work from. This process is called CAD releasing. The CAD math model is the core data for all users. Full implementation of CAD releasing and CAD the Master programs is expected in the 1995 car programs. Ford Motor Company has one of the most efficient data transmission systems in the world. To show how this works, we will bring a part from the other side of the world to our local data collector. You are seeing a real-time demonstration. First, we access the remote data collector. In this case, we'll bring an escort part from a data collector in Hiroshima, Japan. With these menu picks, we'll tell PDGS which part we want. The remote data collector finds the part and sends it to our local data collector. Communications with designers and engineers in other countries on this level could take weeks with paper and models. Our part is listed on the local data collector. Now we can bring the part to our local disk to work on. We can work from this part or make suggestions and send the part back just as quickly. And we have the added benefit of destroying language barriers and the confusion they can cause. As we mentioned, the math model is the core data for many different users. These images show the data model at work in other programs. This program is called NC, or numerical control. Our numerical control programs support cutting and grinding machines used to produce virtually every stamped part of a vehicle. The cutter paths are derived directly from the PDGS data. The time spent manually entering data and the errors introduced by manual methods have been eliminated. This screen shows how the numerical control program plots cutter paths. NC data is directly transferred to a cutting machine. On this machine, NC data even controls the bed which holds and rotates the die as it is cut, as well as the cutter paths. If changes to the original design are approved, new machine control data is generated. This program, called FINS, for Forward Inspection System, develops paths for measuring critical areas of a die or part directly from the original math model. This screen shows the critical path which was developed by FINS for measuring the fender. Checking the physical measurements of a part and the tools used to produce it against expected measurements from the data model ensures that the design intent was met. This coordinate measuring machine, or CMM, is using the path developed by FINS to check our die. The FINS data was transferred directly to the CMM. FINS supports a myriad of coordinate measurement machines to check prototype and production dies and parts. These machines are just a few examples. Users at Body and Assembly project a 5-to-1 savings ratio over manual methods. They also told us that the most dramatic improvement was the accuracy of the parts, coupled with the ability to check parts and pinpoint problems at all stages of development. To quote, they felt this will give Ford the biggest bang for the buck. EDGS, or the Electrical Design Graphics System, was the first full CAD application. Everyone works from the CAD data, eliminating the need for drawings and most of the harness models for checking designs. The EDGS data is used not only to design wiring harnesses, but also to chart the circuits and check for continuity and component compatibility. The EDGS data provides a bill of materials, which is used for ordering, inventory, scheduling, and tooling. EDGS users are designers, engineers, cost estimators, schedulers, suppliers, and manufacturers. This cartoon character represents how EDGS is used to tame today's wiring harness. Here is the beast in real life. This Lincoln Continental wiring harness needs almost 1,200 circuits to operate the electrical equipment. Each component's position in the vehicle has been analyzed for environmental considerations like moisture, dirt, and heat. With EDGS, specifications for components are tracked and can be automatically updated across car lines. The new component exchanger feature updates components 40 times faster than was possible before its implementation. Our products are becoming more and more complex. Without tools like EDGS, it would be impossible to design and manufacture high-quality, robust systems which integrate new electronic features at a reasonable cost. Kinematics models bring parts of a mechanism together to test their function and compatibility before building prototypes. The models are built, the data is processed, and the kinematics models are set into motion. These images show some of the activities which use kinematics models. By using math models of mechanisms, we can study how the components work together under any conditions we want to test. New component technologies can be more readily incorporated into our vehicles by electronically substituting different components in the systems and evaluating the results of the analyses. Instead of the few iterations that manual methods allowed during a car program, we can tune the systems until they meet our exact specifications. FAST, or Finite Analysis Element System, is another engineering analysis program. It shows a structure's ability to support loads. This short demonstration shows a FAST analysis. Our engineer may bring in a PDGS data model or create his own. We'll use this simple bracket for an example. Here, he is specifying the component's properties, what kind of material the part is made of, and its thickness. The data is processed in Nastran, and the plot you see on the screen shows the part's deflection under the specified load. Our engineer can also assign colors to represent the calculated stress on the part. We've chosen red to show the areas with the highest potential for failure. By changing the composition or density of the part and rerunning the analysis, the engineer can predict the specifications of a part which will meet the design criteria. Instead of going through the time-consuming and costly process of building many prototype parts, the prototypes built with the benefits of these analyses are very close to production parts and systems. This video is a very brief look at some of the CAD/CAM tools available today. Our in-house development teams work closely with our users to design and produce the enhancements they need to do a better job. And our twice-per-year release cycle means we can be more responsive to your needs. We have staff members who will work with you to determine how CAD/CAM could benefit you and thus our company. Ford Motor Company is striving to deliver to our customers exciting products of the highest quality at the lowest possible cost. If you need any further information, please call the CAD/CAM Application Support Hotline at 313-845-2592.